All right, we're given three types of receptor cones and their associated frequencies, and we are asked to solve for the wavelength ranges and the corresponding colors. All right, let's start with the equation that we're going to use is the speed of light is equal to wavelength times frequency. We're going to rearrange that to solve for a wavelength. All right, so divide through by frequency, and you got wavelength is equal to the speed of light over frequency. We're going to use that for all of these now. So let's start with the S-type. So the wavelength for the S-type is going to be 2.998 times 10 to the 8 meters per second. That's given to you on your reference sheet. That's the speed of light. And the frequency on one end, the range is 6.00 times 10 to the 14 hertz or per second. So we'll just put that up there, or 1 over seconds is fine too. Either way, the seconds are going to cancel out. So we'll be left with meters. That is the unit for length. Let's go to our calculator. 2.998 times 10 to the 8 divided by 6 times 10 to the 14. Three significant figures is what we need because that's what we're given in the problem. So it's 5.00. Now, remember, frequency and wavelength are inversely related. So we're given the lower range of frequency. This is going to be the higher range of the wavelength. So I'm going to write that up over to the right side here. 5.00 times 10 to the negative 7 meters, which we know that is 500 nanometers. But when you write it like this, actually, these are not significant. So sometimes we'll just put like a decimal there to explicitly say that all those zeros are significant, because they are. All right, so the nanometers, if that looks better for you, then we'll just put that decimal there. All right, let's do the higher range of the frequency, just same setup. 2.998 times 10 to the 8 meters per second. And put the wavelength, or the frequency rather, down below is 7.49 times 10 to the 14 per second. Okay. I'm just going to write that up to the top and save a little bit of screen space. Let's go to our calculator. 2.998 times 10 to the 8 divided by 7.49 times 10 to the 14. All right, so that's going to be the lower range of our wavelength, 4.00. All right, so 4.00 to 5.00 times 10 to the negative 7 meters, or we can say 400, put that decimal there because those zeros are significant, nanometers to 500 nanometers. So there's your answer. The color is going to be, 400 is at the very high energy of the visible light spectrum. I got this copied over here, so let's go from 400 is in the violet range all the way to, what did it say? 500? Yeah, 500. So right at the greenish, so violet to green. Start of green, cyan. Violet to green. All right, so there's the S-type. Let's go to the M-type. All right, let's go with green, because it's kind of overlaps, right? So it's going to be green is going to be one side. It's looking like. All right, so it's just kind of redundant now, right? 2.998 times. You know what? You got that. I'm just going to punch these numbers in our calculator, and then we'll just write it down, because you can see the setup is here. It's going to be the same for all of them. All right, let's just punch these numbers directly in. It's 2.998 times 10 to the 8 divided by, I'm just going to go with the medium cones. I'm going to go from, I'm going to go with the 6.62 first. Let's go left to right this time. On my answer, 6.62 times 10 to the 14. So that's the higher frequency. That's my lower wavelength is what I'm saying. All right, 4.53. Right, so it's 4.53 times 10 to the negative 7 meters, or we can say it's 453 nanometers. Right, so what I was saying is, like, if this is going to be, well, let's just finish this here. What is the other one? So 400, wow, this is all right, 476, 4.76. 4.76. Just copy that number. Copy the previous calculation. All right, let's just replace the coefficient with 4.76. All right, so there's the longer range of the wavelength is 629. 629 nanometers, or we can say 6.29 times 10 to the negative 7 meters. All right, so there it is. Let's look this up on our chart. All right, 453. So that is, these are going to overlap. 453 is right around there-ish, blue. And where's this taking us to? 629. So blue to 600 and red. Blue to red. All right, let's plug in the numbers for the large cones. All right, again, I'm going to go from right to left. That way my answer is written left to right. All right, so here we go. Just copy that and replace the coefficient with 6.00. Oh, we already did that once, right? So it's 500 nanometers. Put that decimal there. You know, it's 3 significant figures. And this time we are going to go from 500 nanometers to 4.28 is the frequency. Let's just copy that. Replace the coefficient. 4.28. All right, it's going to go all the way to red. 7.00. 700 nanometers red. 700 nanometers. All right, so that's going to be 500 to 700. Right around, right there, green to red. Green to red.